Now let's imagine you're traveling from Montego Bay to Kingston and you're traveling on the highway at a constant speed of 60 miles per hour. Now the distance that you travel depends on the amount of time you spend driving. Now let's assume that after driving you have derived an equation for your driving. So you say let y be the distance you travel, and let x, so this is my traveled, and let x be the number of hours you spend traveling. So the number of hours spent traveling, and you derive that equation for your travel to be y is equal to 60x. So that's your equation that you derive that. Now if we were to map the function for the various values, so when you're at 1 hour you travel at 60 miles, you cover a distance of 60 miles, and say when you 1.5 hour you covered 90 miles, within 2 hours you would have covered 120 miles, and within 3 hours you would have covered 180 miles. Now we could graph it. Now we could graph it easily. Let us call this easy. Just want to say 0, 1, 2, 3, and this could be powers of 30. So it's a 30, 60, 90, 120, 150, 180. So we can graph. So just graph 1 and 60, 1.5 and 90. So we get approximately halfway in between here. So, and we can graph 2 and 120, 3 and 180. And we know that if we were at 0, 0, 0 distance, 0 hours will be right here. So when x is 0, plug it into our equation. If x is 0, y is 0. If y is 0, then x is 0. So we realize that we have a straight line. I'm going to use my ruler up. It might look weird, but don't pay attention to the number of feet on it. So I have a straight line going right through the origin. Now, what have we observed from this graph? We have observed that as the x increases, the y value increases. So as the x value increases, the y also increases. So we can say that the more hours we drive, the farther we'll go. So the more hours we spend on the road, the more distance we'll cover. Hence, also, we could assume too that if the value of x decrease, or if the number of hours should decrease, then the distance that we cover would also decrease. So we see that if both variables are increasing at the same time, and both would decrease at the same time. Now, that's our observation. Also, we observe that the graph comes straight through the origin. So we observe, so the graph goes through the origin, and that's my lovely handwriting, so it goes through 0, 0, and as the x value increases, so does the y value. And we know that if the x value should decrease, then the y value would decrease. Now, this is an example of what we call direct variation. And for this example, we can say that the distance traveled y is directly proportional to the time spent traveling x. Or we can say that y varies directly as x. So we can say that y varies directly as x, and note briefly that all direct variation graphs must go through the origin. All direct variation graph, you get a straight line that goes through the origin. It must go through that 0, 0 coordinate right there. So in essence, with direct proportion or direct variation, if one quantity increases, the other increases as well. And if one quantity decreases, the other quantity will also decrease as well. Here are some steps to guide. 1. Write the statement using your proportionality symbol. This symbol right here. Write the equation using a constant of proportionality. In this case, I'm using k. You can use other variables as long as you identify that that variable is your constant of proportionality. 3. Use the information or use the known information to work out the constant of proportionality. So in many cases, they normally give you some known values. For example, they will say A is 3 while B is 10. They always give you a known set. So use the known set to find your constant of proportionality. And finally, after you have found your constant of proportionality, write a new equation with the constant of proportionality. That wants to bite up my tongue. But anyway, use that new equation now to find your unknown values. Now in our next question, it says the circumference of a circle C is given by 2 pi r, where r is the radius. Does C vary directly as r, and b, what is the constant of variation? Now we can just easily look at the question and answer this one. It says C is equal to 2 pi r. C is equal to 2 pi r. So we said the circumference of a circle is equal to 2 pi r. Now we know that the 2 pi r is constant in this equation. So we don't have to worry about the 2 pi r. But if I should change my value of r, it will increase or decrease the value of my circumference. So if I increase my value of r, it will also increase the circumference. If I decrease the value of r, it will also decrease the circumference. So hence I can say that C, the circumference, and the radius are directly proportional, because the larger the radius of the circle, the larger its circumference. Also, if I should decrease the radius of the circle, I'm going to also decrease the circumference of the circle. So there, does C vary directly with R? Yes. And the reason is, again, the larger the radius of the circle, the larger its circumference. If I should decrease my radius, I'm going to decrease my circumference. Alright? Now that's a part A. I won't write out all that explanation. You have heard it. You can write that down for yourself. B says, what is the constant of variation? Now the constant of variation, what is the constant? The constant is what stays constant. What will stay constant throughout me changing up the variables? So if I want to play with R and if I want to play with C, I can go ahead. Those can always change. But what will not change is the 2 pi. So the constant of variation is going to be 2 pi. Alright, on to our next question. It says the amount of stain needed to cover a wood surface is directly proportional to the area of the surface. If 3 pints are required to cover a square deck with a side of 7 feet, how many pints of stain are needed to paint a square deck with a side of 10 feet 6 inches? Alright, so let's highlight the keyword. It says that the amount of stain needed is directly proportional to the area of the surface. So we can define some variables. Let's say let x be, let's call this x, let's call this y, just to get something out of the way. Or you could call it s and you could call it area. Whatever you want to be, just define your variable. So let x be the amount of stain, just so that we can work faster. And let y be the area of the surface. Right? And so therefore we can write our equation first. So x is directly proportional to y. So x is equal to ky. Now they give us the values of x. So if 3 pints are required to cover 7 feet, so therefore when x is equal to 3, y is equal to 7. So we can find our constant of proportionality. That word is going to let me stutter. Anyway, so we have 3 is equal to k times 7, and we divide both sides by 7 to find the value of k. So k is equal to 3 over 7, or 3 over 7 is equal to k. Doesn't matter. So k is our constant of proportionality. So our new equation is x is equal to 3 over 7 y. Now the next part of our question says we are to find how many pints, where the question is asking us to find how many pints of stain are needed to paint a square deck with a side of 10 feet 6 inches. So we know that 12 inches make 1 feet. So 12 inches is equal to 1 foot. So not feet, 1 foot. Hence, if we have 6 inches, that means that we have half a foot. Hence, this 10 feet 6 inches is the same thing as saying 10.5. So in this case, they're asking us to find x when y is equal to 10.5. That's exactly what the question is asking us to do. Find the value of x when y is equal to 10.5. So we use our new equation where we have x is equal to 3 over 7. And anywhere I see y, I'm now going to substitute it with 10.5. So 3 over 7 times 10.5. Let me grab my calculator quickly. So we have 3 times 3. So we have 31.5 over 7. And that gives us 4.5. So we need 4.5 pints of stain. Same thing, more stain, change the color of the thing, like paint. Alright, so 4.5 pints of stain to cover 10.5 feet area. Alright? And we could work this many other ways, but we're just choosing to work it this way for this question. Next question we have, the table shows corresponding values of A and B. So we have A is equal to 3, B is equal to 3, A is equal to 6, B is equal to M, and it says B varies directly as A square. So I like highlight make important information. I like look for when we have common values. I mean when they give us the values of A and when they give us the value of B. So we have B is directly proportional to a square. Our equation is b is equal to ka squared, where k is our constant of proportionality. And we know that when a is 3, b is also 3. So we can plug in our values and find the value of our constant of proportionality. So 3 is equal to k times 3 squared. Now 3 squared is 9. So we have 9k, or k9 is equal to 3. So we're going to divide both sides by 9. So k is equal to 1/3. So since k is equal to 1/3, our equation is now b is equal to 1/3 a squared. Now find the value of m. So m is our b value. So the question is asking us to now find b when a is 6. So find b, which is our m, when a is equal to 6. So using our equation, b is equal to 1/3. Anywhere I see a, I'm going to substitute it for 6. So I now have 1/3 times 6 squared, and 6 squared is 36. So 36 divided by 3 gives us 12. So b is equal to 12. And we found it. We found our m. So find, so therefore, write our statement. The value of m is 12. Now for our last question, the safety possible question. The link to this paper will be in the description. It says the table below shows corresponding values of the variables x and y, where y varies directly as x. So we have y varies directly as x. So in our equation, y is equal to kx. Then it says x is equal to 6, y is 3, x is 10, y is u, x is t, y is 9. Calculate the values of t and u. So we have a known set at all times. So we know that x is equal to 6 when y is equal to 3. So we can substitute our known values into our equation and solve for k, which is our constant of proportionality. This one time might turn all the time. Well, anyway, so we have 3 is equal to 6k. So we apply our substitution here. Divide both sides by 6. So k is equal to 1/2. So our new equation is y is equal to 1/2 k. Sorry, 1/2 x. Sorry about that. Y is equal to 1/2 x. That's our new equation. So if I want to find u, that means finding y when x is equal to 10. So we're going to plug it into our new equation and solve. So find y when x is 10, and that will give us u. So hence y is equal to 1/2 of 10. So y is equal to 5. So we know that u is equal to 5. So the next part, so you can conclude from here, therefore u is equal to 5. Hence, next one wants us to find x when y is equal to 9. Using our new equation, y is equal to 1/2 x. Substituting our values, 9 is equal to 1/2 x. So we're going to find x by multiplying both sides by 2. So 2 times 1/2 give us 1. So we're left with x is equal to 18. So therefore t is equal to 18. So therefore, t is equal to 18. Thanks for watching. See you in our next time, or see you in our next video.